Hello everyone, welcome to my YouTube channel Akash Thing. So today we are going to continue our learning journey on the Python series. So in our last couple of videos, we have learned about the basic understanding of Python. We learned about Python syntax, indentation, and different topics like how to use print statement, print function, and how to use input function, how to deal with variables where the memory is getting used, and we also learned about comment, different ways of that. So with that, today we are going to start a totally new series where we are trying to understand about data types that are there in Python, and mainly we will be covering about this numeric data types, which you can see in the heading itself, which are int, float, and complex. And there are different data types, of course, and we will try to cover them one by one in our upcoming videos. But for now, let's focus on the numeric data types, and we try to see how we can initiate them in Python and what are the different memory limitations of that. So we'll try to mainly touch upon these three topics. We will try to get a high level overview about the different numeric data types and how it's related to the math that we have already studied in our class 8, 9, 10. And then we'll also try to see how to implement that in Python and what is the memory allocation around that that is going at the backend. And then we'll also try to compare the storage, like in which bucket Python is storing the different uh, things related to these data types so that you can optimally use these resources. So with that, let's get started and let's go to this. Let's see this table and let's try to understand about the data, numeric data type. So at first, let me talk about natural numbers, whole numbers, and integer number and the decimal numbers. So I hope you all must have read about it in your class, like in your childhood mainly. So let's try to revise it. So first comes our natural number. Why? Because natural number starts from 1 and it goes to 2, 3, 4 till infinity. Infinity is a very large number which you can't even imagine. Then comes your whole number. So whole number is nothing but 0 plus natural number, which is 0, 1, 2, 3, and till infinity. So both of these does not include the negative numbers, and that's where this integer comes. You can say integer number is nothing but minus infinity to minus 1 plus whole number. Or you can also say it as minus infinity to 0 plus natural number. So natural number and whole number both you can say is a subset of integer or a part of integer number. Now let's try to represent it on the scale. So if this is my scale where this is 0, this is infinity, and this is minus infinity, then this piece will be my natural number. And if I include 0, then this piece will become my whole number. And if I cover from here till here, this is my integer number. So now I hope you're clear with this concept because it's important to understand it, and then only you will be able to relate with what is int, what is float, and yeah, for complex will come. So yeah, now all these comes in the integer part only. So this integer is nothing but it's a whole number of unlimited length. For example, 42, and it is used mainly for counting. Counting as in like if I have to count how many books I read. So I will go with one, two, three. That's where it's saying it as an example. For indexing, indexing is like if I have 100 rows of data in my Excel. So how will I count? One, two, three, same, right? For loop also, like if I have to run a for loop for I in range 5, it will print like 0, 1, 2, 3, so something like that. So that's where these are the couple of use cases which we are going to use it very often. So this is now you got understanding about integer. Now let's try to understand the decimal or float. So let's say this is my scale x-axis and I have values here 1 and then 2 and this is 0. Now I can split this into, let's say, 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what is this distance? If it is 1 and I split it into 10, it will be 1 by 10, right? So this pointer will become what? 1 by 10, which is equal to 0.1. Similarly, this pointer will become 0.2. This will become 0.3 and till this will become zero point 0.9 and this is what? 1 or 1.0. It keeps on adding, like we are adding zero point 0.1 to all of them. So it's kind of a fraction, right? 0.1 or 1 by 10 is a fraction which we converted into decimal. And that's where this float comes in picture. Now this is at kind of a round figure 1. We can also define it as 1.11, 0.11. We can also define it 0.1111 up to n number of like places, right? So all these will become my decimal. Even the negative values like 0.1 or minus 3.1 or minus 4.325. So all these are also decimal number. Or you can say it as float in Python. So this is the description that is saying fraction or a decimal. For example, 3.14, and it's mainly used for measurements or financial prices or other things as well, like measuring the width or the gap or kind of some other measurement that might be there. So hope you also understood this float on high level. Now coming the complex. So you might have studied in your 3D classes. If not, then it's like think of this complex number as two axes. One is my real axis and second is my imaginary axis. Real axis is something that you can understand, you can read, like number one, number two, you can understand and relate it. Okay, one represents one thing. Imaginary is nothing but root of minus one, which you can't like visualize, but this exists. Matlab, exist in virtual world. Now, if I have to represent a complex number, it can be like, let's say this is my 1 and 1 on both the axes, then this can be my virtual kind of complex number, which can be represented as 1 plus j. So this j is nothing but root of minus 1. Similarly, if I define a point here, then how we can represent it? Real axis 2 plus imaginary axis 3. So this will become my complex number. And here it's 2 plus 3j. So that will be 2 plus 3j. This is same, right? And it is having several implications in physics, signal processing, and in 3D geometry. So all those places we have this used. But yeah, in data science, we rarely use this. So now I hope you understood it on high level. So let's go and try to understand these topics with some practical implementation. No more theory. So now let's just, I have added some pointers just for you to go through it and read. I will try to load this on GitHub and we'll share the link in the below like YouTube. So, so now let's try to understand how we try to create the integer number in Python. So it's simple. We give it a variable name and we use this assignment operator equal to, and then we assign the integer value. So it can be 105 or it can be 100 or 10 or 1 or minus 10. Can be anything, right? So this way we try to create this integer. Now, if my integer is in millions, billions, trillions, so at that time, if I try to write values like 10000000000, so it really becomes difficult. And that's where in Excel or in some other places, we try to put comma here. So instead of comma in Python, we have this underscore thing that represents the same thing and it allows easy readability without overflow. Overflow means it does not go out of the memory, but it stays inside it. So that's where this thing comes in picture. Now this is the other representation of integer in Python, and then there is one more representation which is kind of binary number. So let me help you understand this, how to read this. So 0v is the indication that this is a binary number. Again, there can be a hexa number, or there can be uh, other format as well, but 0v represents nothing but the binary indication, and the value after that, that is 1010, is my binary number. So if we try to break it, you can read it like 1 2 4 8 60. It's like 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, similarly. And then 1010 is nothing but 1010. And then what we do is like we multiply these two. So this will become 1, this will become 0, this will become 2, and then this is 0. Now we add this, and the value we get is the integer. So you can see we have this 10 here. Now once we run this value, we will try to print and see the actual value that is coming up. Also, I missed to say that this was not in the earlier version of Python. Only it's introduced after Python, like in Python 3.6 or above that. So let's try to run this and see how it's working. Yeah, we ran it. Let's try to print the value count. Now count is coming as 105, and if we modify this value to 2000 and print count, it is still going to work. If I can have a minus before it, it's still going to work. But if we write something like 0 1, then it's not going to work. It will fail. We'll say that this leading 0 is in decimal integer later, not permitted here. Okay, so just we like sure about using 0 before it. So yeah, other than that, everything will work. Similarly, let's try to print this large number here. So it's also working, right? Stating as normal. And then let's try to print the binary number also. So binary is also working. You can see the value that we got is 10, which we calculated, right? Also. Now, if I try to add a binary and count, will it work? Let's try to see. Yeah, it's working, right? Count was 10 and binary is 10. If I multiply count by 2 and then add, it's also working. And if I multiply this by 5 and let's see, this is also working. Now, similarly for large number, let's try to do this. Let's say I have this large number equal to this, and let's multiply large, let's add 1 to this large number and see what we get. So this will work actually. There is no problem. You can see we are getting the round figure. So yeah, now let's try to understand something about these integers and how this integer data size keeps on increasing as we increase the number of values inside this integer. So if my value is just 123, very small, then the data storage, which we like here, we are using this sys.get size of. So you don't need to understand this in deep. If you're interested, you can go for sure. But this is nothing but calculates the memory occupied by this particular variable in bytes. So let's try to compute this for small number, then large number, and then huge number, which is like having power of 50, which is like 1 followed by 100 0. So let's try to run and see the memory size. So you can see the memory size is 28 just for a smaller number, which is the smallest. And then it keeps on increasing in multiple of 4. So from 28 plus 4, it is 32. And then if we further increase, it becomes 48, which is again kind of a 16 increase, which is multiple of 4 only. And if we make it 100 also, it is going to give 72. But there is a limit to which we can increase huge number also. So let's try to see that also. So in like 2026 in modern Python, this string conversion limits came in picture. And that came because when we have a huge number, huge integer, very big integer, and we try to print that, it first converts into string, and that's where it occupies a lot of memory in computing that. And there is a chance that if someone is just hosting a website, and the hacker tries to pass a password which is very lengthy, something in this range, 10 to the power 5000 or 10,000, then the system may hang, and it may take some additional time to process that. And that way, the others people who will try to access that website at that time will feel like the system crash and it's not responding, because the system gets busy in computing that, or in uh, storing that basically. So that's where it is considered as a security threat, denial of service, and that's where Python set this limit of 4,300 digits in 2026. Earlier it was not there, but yeah, let's try to see if it is actually there or not. So for 4299, which is 4,300 digits, let's try to run. So you can see it is working fine, and it is consuming around 1932 bytes, which is quite huge, like around 1 point some MB. Now, if I increase it to 4,300 and let's try to run it, you see there is a error. Exceeds the limit 4,300 digit. Now there is again a thing that is there through which we can increase this limit. But generally it's suggested not to increase the limit above this. So again, we can either increase the limit to 10,000 using this parameter, set int max string digit, or we can just remove any limit. So it can be any number, depends upon the computation that our system offers. So let's try to run this same thing like 10 to power 5000 or above 4300 here, and see if it works after resetting the limit. You can see it's working fine, right? Okay, so this is what I wanted to explain here, and I hope it's a new thing for you and you came to know about this, that integer can be expanded and it can consume huge amount of space and it can be increased to any limit. Now let's try to understand about the second data type, which is float. Without wasting any time, let's try to directly go into the code. And here you can see like three ways in which we can write this float. First is the general way which we write in maths and other places, which is something point and something. So before point we read it as 19, and after point we read it as 9 instead of 99. And then the for negative decimal points we have to write minus before this number. And then there is scientific way to represent the decimal, which is power of e. So e can be a small or capital, doesn't matter, but what it represents is if it is e to power 3, that means it's multiplied by 10 to the power 3. So let's try to run and see first the value we are getting. So let's try to print it one by one. So price, you can see I'm getting 19.99. And if I try to add some values to it and see, so this is working fine. Now we'll talk about this in our next video in the advanced lecture. For now, let's try to stick to it, and let's try to add, let's say, 20.5 plus 20, which is 40.5. Now 20.5 plus 5, this is also working. So, hope you got this clear. Now, let's try to print distance also and see how distance behaves. So, zero point 0.5, and if we try to subtract price and distance, we'll get something around 19.45. Sorry, since it's negative, it will add up. So, that's why this is. If we just add this, then it will subtract. So, 19.49. So, yeah, this is also working fine. And we can also just try to create this scientific, run this scientific value, and you will see like 35,000 will come. And let's try to define something like 3 capital E 3. So this is nothing but 3000, right? See, it's working. Now can we add some number to it? Let's see. 100.0, 100.11. See what is coming. So it's working, right? And we can also subtract that much number. So yeah, all these things we can do. So all these three can interact together. It's not a problem. Now let's talk about the complex number. Again, in complex number, we can also, like we already learned about this complex number. So let's just go into the code, try to run this. And here we have this flexibility that we can also fetch the real value and the imaginary value. So for that, we have this real and image command, and we can pull that. So let's try to run and see what it gives the output. So you can see it gave me the real as 3 and imaginary as 4. If I just print this num, let's see what will come. So num is giving 3 plus 4j in a kind of pointer. If we try to print the type of this, I think it will be mostly complex. See. Similarly, I think I forgot to show the type of these scientific. So here, if I write type, you can see the type is float. And for similarly for int also, if we try to print, let's say type of count, it will be int. So yeah, this we can check at any time using this type constructor or the function. Now there is one thing that we can check here. So can we have a negative value in a complex number? Let's try to do it for both real and the non-real term. And let's try to print. So yeah, it's working. It's not a issue. Now let's try to have some decimal values for real. This is also working. And for imaginary, this is also working. So we can do all these manipulation. Let's try to also use the E and see if it works. Yeah, this is also working. So we can have E as well. So hope this give you more clarity on around this. Now, one thing we should test is like if we remove this, will it create this complex number? Okay, let's try to check the data type. Yeah, it's coming complex. But if I remove this part, uh, like if I remove the value, just keep as j, will it come as? So it's not coming. I need to have at least some value, even 1 is fine. If I just keep it 0, it will also give a output, and let's try to fetch the real piece and the imaginary part here. Let's see what will come. I think for real it will come 0, 0.0, for imaginary also 0. Yeah, so this is how you create a 0 by 0. And you can also create it like this as well. I think there is no problem in that. Yeah. And what if I add minus in front of this? Will it do some implication? No problem. So it's also treating minus also as same. But here it's treating differently, the imaginary part. You can see it's adding minus 0 instead of 0. So this we have to be careful, and this is what I have tried to write here. So when we try to print z dot real, if we just have the imaginary piece, the real piece will also be defined and it will be 0, 0.0, which will occupy memory. And if we are doing some string kind of manipulation, then this 0, 0.0 versus minus 0, 0.0 can be completely two different string, especially as binary storage. So, and that's where it's important if someone who is dealing with these kind of data, and they should be aware about this. That's the kind of just a understanding good to have. Okay, so now as I can see, the video already got long. So let's try to wrap it up here only. And in our next video, I will try to cover these advanced topics and also the memory storage comparison, which is again a very good interview question, or very uh, someone should have this understanding so that they can understand deeply how these integers or float are actually consuming the space inside the memory. So all those things we'll try to cover in our next video. So With that, I would like to thank you and hope you had some good learnings here. So yeah, thank you. Like, subscribe, and share.